Skill 38, Parallel and Perpendicular Lines. In this skill, our goals are going to be to determine if lines are parallel, perpendicular, or neither, and then to write an equation of a parallel and perpendicular lines based on a given line through a given point. Parallel lines are two lines that will never touch and will have the same slope. Perpendicular lines, on the other hand, will intersect at exactly 90-degree angle and have opposite reciprocal slopes. The key concept here is the slope. The slope of parallel lines is going to be the same as the slope of the original. So M parallel is going to equal the original M of whatever line we're dealing with. So once we identify the new M, then we are going to put it into our point slope form or slope intercept form. Which is y minus y1 equals mx minus x1, and then simplify it down to y equals mx plus b format. Okay, but really the key concept is to find our slopes. So for perpendicular lines, we have a little bit more work to do on that one. The slope of the perpendicular line is going to be opposite sign, opposite fraction. So flip the sign, flip the fraction, opposite reciprocal. Okay, so just think, flip the sign, flip the fraction. And that's how you would find your slope of your perpendicular. And then after you find the slope of your perpendicular, then again, you can do y minus y1 equals m, x minus x1, and then just substitute your numbers in and solve for y, which is your slope-intercept form. Okay, so really the key concept here, what we really need to be focusing on, is finding the slopes. Because once you find the slopes, then it's just going back to doing the same thing that we were doing before. So we're going to write an equation of a line that is parallel to our original line here, y equals 2/3 x minus 1. And it's going to pass through the point 12, 5. Okay, so I want to first find my slope, and I see the slope of my original line is 2/3. So because M parallel is equal to the original M, that must mean it is also 2/3. Once I have my M, then I'm going to use y minus y1 equals mx minus x1. Because I have a point right here, x1, y1 point. So I'm going to just put the numbers in and very carefully solve it out. Y minus 5 equals 2/3, because the m's are the same, x minus 12. Then I'm just going to solve this out for y. So I have to distribute in my 2/3. Y minus 5 equals 2/3 x minus 2/3 times a negative 12 is 8. Okay, and continue solving by adding the 5. And my final answer is y equals 2/3 x minus 3, because negative 8 plus 5 is a negative 3. So that is the final answer in slope-intercept form. For this next example, we want to identify if these lines are parallel, perpendicular, or neither. So to do that, it would be easiest to put them all in to slope-intercept form, which is y equals mx plus b. And then look at the slopes. If the slopes are the same, they're parallel. If they are opposite sign and opposite fractions, then they're perpendicular. And if they're not either one of those things, then it's neither. So that is how I'm going to do this. This first one, 4y equals negative 5x plus 12. Well, it's not solved for y, so I want it to be solved for y to be in slope-intercept form. So I'm going to divide by 4. Giving me y equals negative 5 over 4x plus 3. I don't really care about the plus 3 because I'm only really focused on the slope when I'm trying to find parallel or perpendicular. So I'm going to look at my slope of 5/4 there, negative 5/4. And then on the other one, it is already in y equals mx plus b format, so I can just find my slope being right there before the x, 4/5. So I need to compare negative 5/4 and 4/5 as my m's. Okay, well, if I flip the sign of this first one, make it a positive, and flip the fraction over, then I have 4/5. Positive 4/5 is the same as the other one, so that would mean that these are perpendicular lines. Okay, and the next example here, 6y minus x equals negative x plus 6. All right, so if I'm solving the first one for y, I'm going to divide by 6, divide by 6, divide by 6, and y equals negative 1 over 6 x plus 1. If I don't have a number before a variable, I imply that it's a 1 like that. So my slope of this first one is negative 1/6. So I want to see if the other one is the same or opposite reciprocals. So if the next one is already in slope-intercept form. The number before the x is negative 1/6. So we have m of negative 1/6 for the first one, and we have an m of negative 1/6 for the second one. Those are obviously the same number, so that means they are parallel lines. For this next example, we are asked to write a line of a perpendicular, equation of a perpendicular line through the point 2, 4, that's perpendicular to 1/3 x minus 1. So the first thing I want to do is identify the slope of the original. The original m is 1/3. If I want the perpendicular m, then I'm going to flip the fraction. So it's going to be 3 over 1, or 3, and then flip the sign. Right now, it is positive, so if I flip the sign and make it negative. So my perpendicular slope is negative 3. So now I'm going to use that slope and that point right there and use y minus y1 equals m x minus x1. And then I'm going to very carefully put my numbers in where they belong. Y minus 4 equals negative 3 x minus 2. Then solve for the x, or solve for the y. So distribute. Negative 3x plus, because negative 3 times a negative 2 is a double negative, making it a positive 6. Add the 4. And y equals negative 3x plus 10 would be the perpendicular through the point 2, 4, that is perpendicular to the line 1/3 x minus 1. In this next example, we want a line that contains 2 points, 0, 8 and 12, 0, and we want to find the equation of a line that is parallel to it that goes to the point 12, 10. Okay, so there's a couple ways to look at it. Kind of a good common way to look at it would be just find the slope and then find your parallel line through that point. So that's what we're going to do. Remember that our slope equation, y1 minus y2 over x1 minus x2. So that would be 8 minus 0 over 0 minus 12, giving me 8 over negative 12. Simplify that down just to make it a little easier. So that would be a negative 2/3. So that is our slope. And then we have to identify our parallel slope. Well, that's kind of easy because m parallel is going to be the same as our original m. So it's also going to be negative 2/3. And then I can go y minus y1 equals m, x minus x1, point slope form, put my numbers in, y minus the point that I want it to go through, 10, equals negative 2/3, x minus 12. Now solve for y. Y minus 10 equals negative 2/3 x minus double negative, actually, minus the negative, so plus 8. And continue solving, so I'm going to add 10 to both sides, giving me y equals negative 2/3 x plus 18. And that would be the equation of your parallel line through the point 12, 10. So we're going to do one more example here. Given the point and the original equation, we want to find a parallel and perpendicular. So first thing, we're going to find the parallel. M parallel is going to be the same as the original m. The original m is 1/2 right there. So m parallel is 1/2. And then y minus y1 equals m x minus x1. And then we solve. Put our numbers in and solve. Y minus 2 equals 1/2 x minus 3. Distribute in. Y minus 2 equals 1/2 x minus 3/2. I'm going to add the 2 over. Negative 1/2 plus 2. Y equals 1/2 x plus 1/2. And that would be the equation of your parallel line. Next one, we want to find the perpendicular. So m perpendicular. Flip the sign. Instead of it being a positive, it's going to be a negative. And flip the fraction. Instead of being 1/2, it'll be 2/1. Y minus y1 equals m x minus x1. Put in our numbers and solve. Y minus 2 equals negative 2x minus 3. Distribute. Y minus 2 equals negative 2x plus 6. Add the 2 over. Y equals negative 2x plus 8. And that is your perpendicular line through that point, perpendicular to the original y equals 1/2 x plus 4. That is it for your notes on parallel and perpendicular lines. You should be able to do the homework now. I would like you to look at the first two of each section and then get prepared for a quiz.